Okay, so today we're going to be taking a look at an 820-3437 that shows no image on the screen. Now there's a few things to go over on MacBook Airs that have no image, and I'm going to go over a few of those right now. So here's our tester screen that works for the most part. We're going to plug this in and put this in view in a minute. We're going to plug it in. These are going to go through their spin stop things, but you're going to see in 1 second that you're probably going to see nothing but black because the screen doesn't work on this. So I'll give it a couple minutes, and in the meantime I want to also plug in a USB mouse. Now you may think when you get one, well, no image, it must be the GPU or the CPU, I must reflow it. No, stop reflowing stuff. I can't tell you the amount of people that have been posting on the MacBook Logic Board repair support group that tell people, oh, just reflow the CPU, I had one that worked like this. No, use your brain, do not reflow anything. I'm getting sick and tired of seeing stuff that comes in with the melted plastic on the CPU because someone doesn't know how to use their brain. I'm going to try and plug in this USB mouse. And, oh, look, the screen works. Okay, so you see that? See how it's like halfway? Let's look. It works. Halfway. There's some distortion, and that's not the cable. Actually, that may be... No, it's the LVDS area or something in this area when I push down. So let's take a look at this, since the board seems to have fixed itself. But just because it works doesn't mean there isn't a problem in that area. Sometimes you may have an intermittent fault. That intermittent fault may only present itself at certain temperatures, or who knows. Moving the board from the shelf to over here may have moved around whatever component it was and allowed it to work again. So don't assume that something is fixed because you see it turn on. Okay, so we're going to have a look at the area of the board, especially near the screen. And let's see. Focus this camera. Okay, so here's our screen circuit, and you notice this doesn't look too happy. It looks like there's some liquid in this area. This the shield looks really bad, and I wonder what this stuff does right here. I wonder if this chip right here, all the corrosion has something to do with our 3.3 volt circuit for LCD power. The LVDS connector doesn't look too bad, but that looks pretty corroded, and this whole board looks kind of, let's see. Yeah, that looks pretty. What this board looks like is it was put in a cheap ultrasonic cleaner. A lot of times people use these cheap $100 cleaners and they just don't really cut it. You can see the whole color. It shows up a lot more on in person than on camera, but if you look at this, it just looks this doesn't look like liquid damage to me. This just looks like, cheap ultrasonic cleaner, too hot, too long kind of thing. And the majority of these probe points are falling apart, but most of these right here are just going to be for testing and not for anything important. I'm surprised this thing works. So we're going to address the first issue, which is what it came in for, was no video, and then get to the rest of this stuff. It does look like the BIOS area spared the hit, though. Let's see. Yeah, it just looks like. Okay, so let's have a look at this angle. Let's see what's under the shield, what's lurking under the shield, because I bet there's something interesting under here. See if I can even pop the shield up, because it's stuck on there so good from. And yeah, that's pretty bad. This could use a good reflow. Look at all that stuff that came out of that. That is no good. Okay. Let's open up the schematic and board view for an 820-3437. So first off, wait a second. I don't even have to open a schematic now because Flex Board View does that for me. So this is a 3437. Also note, if you ever come across, let's say if you don't have a board view for a 00165 or something, the 3437 will work just fine. There's very little differences. There's some, but not really many. Let's find it here. Okay, so if we look at our screen circuit over here, where all the corrosion was, especially near this chip. This chip is for Thunderbolt. We're not going to be too concerned about this. I'll reflow this, but Thunderbolt isn't really my concern. So my main area of concern was one right here, which is our PP3V3 SOSW LCD line. This is going to be our main power supply for our screen circuit. So if this chip was corroded, which by the look of it, it was corroded at one point in time, that could definitely impede screen function. And also these resistors in this area were pretty corroded, but mainly these are for backlight. Our image lines, our DisplayPort lines look pretty decent. They weren't the best, but I think that these resistors right here will be okay with just a quick touch-up. So let's go ahead and get started. So the first thing I'm going to do is go ahead and, with all this stuff that just looks nasty, I'm just going to go ahead and take it all off. So fume extractor is going on. I'm sure the fume extractor is pretty loud at that point, so I'm going to do my best here. So we're going to start out with a nice amount of flux right here. The proper amount of flux when you're working on liquid damaged devices. And don't let anyone tell you otherwise. Probably get more flux. Yeah, I really bet that this circuit was doing its job properly. Look at this, we're barely was making contact. That's why we had intermittent fault, because this was probably barely touching. Look at this, it's all falling apart. Just cleaning all this up, and then we'll wick it all away, but I just want to get rid of all this oxidation right here. This tends to happen when you leave boards in the look at this, so yeah, it was just falling apart. When you leave boards in the ultrasonic cleaner too long, this is what happens. Some of the cheaper cleaners that do not have sweep function, for one, try and get a different one, a better one. If you can't, don't leave the board in there for more than 3 minutes aside. If you have sweep, you could go a little bit longer. I tend to go 4 minutes on each side, and my ultrasonic cleaner is actually a little bit more powerful than the Crest, and I'm fine because it has a very good sweep function. The sweep function helps prevent the board just getting blasted at one point in time, and when ultrasonic cleaners that don't have a sweep function, this kind of stuff tends to happen where the whole board just gets destroyed from it. My current cleaner recommendation is the SharperTech XPS 240. However, since it won't fit the larger touch bar boards in, so if you get a lot of those, then I recommend the Crest PowerSonic 1200 or whatever it is. It's the big Crest. Either cleaner, Crest or SharperTech, you can't really go wrong. For the size though, in the 6 liter or whatever size it is, the SharperTech XPS 240 does beat the Crest. Yeah, this board is pretty corroded. Surprised it even turns on, but alright, let's go get a donor board. I'm gonna get rid of this USB thing too. Even though we know it works, we know it was corroded. Why leave it on? I don't like to leave corroded stuff on the board because it tends to fail, and you would think, well, it's just USB, it's just going to be the USB port's not working. Well, no, usually it's going to short to ground and hold down a main power rail. And these tweezers are terrible. Here's a better pair. our last cap right here, which I'm guessing, I have to look at the schematic to see what this one does. But this one is semi-important. We're good to go there. Do we want to take off this USB thing? The pins look good on that, so I'm gonna leave that on and we'll take the chance. I don't think there'll be a problem though. We've got to take care of this thing though. This is one of the controllers for Thunderbolt. You can't see it very well. But what I'm going to do is put a lot of flux around this thing and just give it a good reflow. We don't want to go too hot on this, but we're going to go hot enough. Try and move it a little bit so you can see. I all that junk. This stuff isn't too much of a concern. This will come off in the ultrasonic, no problem. We don't want to leave this one in there for too long. This is not good right here. See these inductors? So these inductors, see this coloring on them? This is actually rust. So this tells me that the CPU area got hit with liquid at one time. However, these FETs look okay. They're not dead yet. They're probably not going to die. But that just means water got over here. So these guys are probably going to go because they're going to be all messed up on the inside. Here's a problem right here. So here's the next problem we need to address. This connector is a huge pain to replace. Basically the only way that I've been able to do them is bottom side heat and drop them on and hope it gets to the right area. So see this, how it's all corroded and nasty. This is our 3V42 line going in. What we're going to do is put some flux here and touch this up. We don't want to get too much on there, and we're going to put a little bit on here and give it a little bit of heat just to remove that corrosion, but for the most part we don't want to heat that up too much because it'll melt. So we're going to take our iron, we're going to go to a lower temperature like 640 and try and clean this corrosion up. This is one of the things I like about the JSO2 tip, is it's like a little hook, so it allows you to get into places like this. Just kind of going to scrape while putting a little bit of solder there. Once the corrosion is cleaned off of these pads, we'll be able to take a little bit of solder, but you could see that how these are in pretty bad condition. There's that one. Kind of gonna scrape away and make a little bit of a bridge because, yeah, these traces underneath are no good. Trying to keep it in view, but it's kind of difficult. You know what, I wonder if I can turn my microscope head a little bit. I can. Perfect. So if I do this, you can see it much better. Get a little fresh flux in there because the tends to break down with heat. We're just going to keep doing this, but I also want to be gentle not to break any of the pins that are already corroded and falling apart. Because these pads under there are no good. I'll take my tweezers and kind of expose some of the copper right there. Especially on our 3V42 one. You can see the 3V42 pin, the one I'm scraping right now, is the worst. It's just there. Now that's cleaned up. We'll do the same. This one's not that bad because we can get some in there because it already has some solder on there. But like this. Now all that nasty stuff we cleaned up, we don't want any of that going under the connector into our solder joint, so we're going to clean this up. Much cleaner. And now we can reconnect those pins. Put more flux down. You can see how bad this connector was, so we're going to reflow this thing at like 250 degrees. And those are now connected. All the other pins look okay, but the connector as a whole, you may not be able to see this on camera, but I can. So what we're going to do is put a little flux down. A little more flux, I should say, around the whole thing. And we're going to reflow the connector at like, 1 second here. We're going to reflow the connector at a low temperature, like 250 degrees. 250 isn't going to be enough to melt it, but it's going to be enough to activate the flux and kind of clean all the corrosion out underneath. And the rest of that, like this little bit of corrosion right under here, That'll come right off in the ultrasonic. That doesn't look bad. It's all loosened now and should be good to go. Let's see. On this side has our SMC. The SMC area looks good. It doesn't look like it took a hit. It's common for the SMC area to these caps seem to be a pretty popular target. When those are corroded, I just take the edge bonding off and reflow the whole thing. And now that I say that, I see these guys right here, which are just destroyed. Yeah, you know what? Look at this. This whole area is pretty messed up. So, I'm surprised this board worked. First things first is we're going to heat the SMC up. We're going to go around 250. Everyone tends like 100 for taking off the edge bonding, but sometimes I'll even do 450. I'm going to take the edge bonding off at 430 Celsius, and I'll show you why. So this is 430. Just be careful on your heat, and it comes right off like butter. We don't want to leave any under there, but it's not. This is already brittle as it is, but I think we'll get most of it. It's a beginner mistake that they don't remove all the edge bonding before reflowing it. But I don't think we're going to have any issues here. As long as we get most of it. There was one on this side that we didn't get at all. So let's have a look and see what that looks like if you don't remove it. See, like, this isn't that big of a deal. Just make sure most of it is gone, and you'll be fine. Worst comes to worst, you either reflow it again or you reball it. Not a big deal. At least reballing SMCs for me isn't a huge deal. I'm decent at them. I don't mind doing them. They're not the funnest thing to do, but I'd rather take an SMC over a CD3215. It's like avocado. No, SMCs aren't too hard for anyone anymore. Let's create a chip. Let's put a chip on the board that's even harder than that. Not only that, let's put it in an area that's susceptible for liquid damage. See how it's moving? I'm just going to tap it. Well, it was moving until I looked off screen. Just tap it like that, make sure it's liquid on all the balls, and it is, so we're good. Now, this area is completely destroyed. Some of these didn't even have a connection, so first things first is we need to restore some of these pads, which looks real fun. This whole area was charred. I don't know how this thing turned on. Alright, so this probe point is destroyed, so we're gonna have to run a little jumper, I'm sure. Maybe not. I think we may have pad under here. I can't tell from there. So let's alright, so see this little thing in here? This is a via. Now hopefully this via isn't going anything to under the SMC or anything like that. There's nothing left under there, is there? Nope, only PCB substrate. Alright, let's see where those go to. Okay. Oh, these are just a 3v42, no big deal. That's probably why they burned out. These all are pretty important. One mistake I see from a lot of shops is they fix the problem. I don't know if it's something they do intentional to get more money or what it is, but they fix the problem and they leave stuff like this. They'll put in the ultrasonic clearance and says, oh, it works, let's charge the customer and let's give it back. But you guys need to do overviews of the board. Because just because it works doesn't mean there's a problem. Doesn't mean that there's no problems with the board. It's like this board. This thing turned on, but you see how bad this was? You know, you can't give this back to a customer like this. It's going to die in a week. Like this resistor too. The crystals, we don't really have to worry too much about those. Those barely die. Just kind of trying to clean up all the oxidation on these probe points, and so far so good. This one is pretty bad. Now what we're going to do is wick all this up, clean it up, put fresh flux and fresh solder on it, and with my multimeter falling, put fresh solder and fresh flux, put all that stuff back, and we'll test it. I think the fan circuit on this is messed up too. Who needs a fan though? I don't need a fan. MacBook will be just fine without a fan. Fan is like Thunderbolt. It's an Intel ultra low voltage CPU. It'll be fine without a fan. Alright, let's clean all this old junk up. Much better. So what we're gonna do is now start replacing all this stuff. So start pulling all this off of the donor and make sure the donor has it, and it does. So these 4 caps right here, these are just decoupling caps. We could do without it, but these ones aren't. So you may notice I'm using 2 different kinds of flux. One is Amtech NC559 and one is Amtech VS213-A. The VS VS2 1.3 tends to be better for making cleaner joints, but whatever is in it, it's not soluble by the ultrasonic cleaner, so that's a problem. Sorry about the blurriness. The camera tends to lose focus really easily, so you have to constantly mess with it. I need to get a different C-mount adapter because this one is terrible. We're going to save these last two for last because else they'll blow away doing the other ones. I know these are out of place. I just like to tack them down first, and then what we're going to do is add some more flux and go over these and properly reflow them. And they'll go in place like factory. None of that. Now these last two. Oh, look at the mess I just made. Okay, whatever. This stuff happens. if you're another tech and you just laughed at that, you're probably going to do the same thing tomorrow. It makes it even worse when your hands are not very steady like mine. Mine aren't terrible, but they're not the greatest. Yeah, see, look. This is how my hands are. So. Not the best for doing this, but I make it work. Alright, you may notice that this looks like a kindergartner soldered. This and these now. These two are naturally going to go to this together because they're on the same pad. These are crooked because there's no other pad right here to stabilize it, and I'm not a robot. We're going to run a wire to these. These again they're on the same pad. This one will touch up. So we have to find PB3B42. 1 second, I have to clean flux off my hand. I don't like any flux in my hand. Okay. So we're going to steal PP3B42 from some place that makes sense. When I run jumper wires, I kind of want to steal it from some place that's not going to make the wire cramped or touching someplace where I'll show you. So if you look right here, we could run it from here, but it's going to kink and it's going to risk breaking right here. So I'm going to try and take one from like one of these right here, like one of these caps, as that's going to be most direct. And it won't kink it too bad or anything like that. So these are all coated wires too. So we're going to run a wire across 2 or 3 of those, it doesn't really matter. third one, yeah, the third one is 3V42 as well, so we're just going to connect it. Why not? Perfect length wire. And those caps are really soldered badly. Not badly, just messy. Again, that doesn't matter. We kind of want to avoid touching this on any probe point, just in case any of that enamel got burned away. I'm just going to go like this. Not the prettiest wire. I want to make sure it's not touching this signal. It's not. We'll make sure to conformal coat that. And yeah, that's not the best wire, but it'll work. What's up with this camera? It's real kind of blurry. It needs a C-mount adapter. Plus the flux doesn't help. Alright, let's see, is there anything else? That resistor, let me knock that resistor out real quick. Most of the times when a resistor is corroded, you can get away by touching it up. It's not like a resistor is going to fail down the line. It's rare. Usually a resistor only fails from a short to ground. Rarely in one case, yeah, you know what? Just get out of here. Rarely they just go open for no reason. Usually due to sulfur buildup within the resistor. There was one area that needed to be addressed, if I remember correctly. I knew there was something. Ah, right here. Okay, so this clock is for something I have no idea what it is. It doesn't seem important, so now, the reason why I replaced this crystal is because, see this? It was the corner was eaten away, and we can't trust that. When the corners are eaten away like that, then Pads came out just fine. This via is pretty corroded. When they're all nasty like that, I like to get a film of solder over them just so they don't get torn up in the ultrasonic. For the most part, these are okay though. Oh, crystal. I know, they're soldered sloppily. We're gonna fix that. No, you get back there. I see what you're trying to do. You're trying to fly away. Yeah, for the most part, the rest of this stuff will be okay. Let's let the board cool a little bit. Let's clean all the flux up. I don't want the flux getting in the connector and impeding testing. Oh, good. We'll work on the other side of the board right there so it's nice and hot so the flux will come right off. Most of it, it's going to go for the ultrasonic so it doesn't. No, you other techs that work on MacBook boards and stuff, don't you hate when you want to, another repair shop prepays for a board and then they prepay for it and then they said, oh, we just had it out but we didn't really find anything, and then you get it and it's like filled with flux. Flux remover. I just want it to kind of thin out so it won't go in my screen circuit or in my screen connector, because that could prevent an image from showing on the screen. Okay, let's grab our screen. Maybe we're better, maybe we're worse. Maybe this doesn't even turn on anymore. Kind of doubt that, but. Under this thing. Okay. Notice I'm testing the board with the wrong DC in board. That doesn't matter much. I'm going to measure for V-core in a minute here. So these boards are going to do the RTC reset or whatever it is, where they spin and stop and spin and stop. And any of you guys that have worked on these 34, 37s know this. So measure for V-core. I don't see anything on the screen yet. We have 1.73 volts on CPU V-core, which is basically fan spin. And we actually do have a backlight on the screen. Let's see. See if we get an image. Now we have an image again. We had one before, but yeah, you could have seen that capacitor in that circuit that was most likely making intermittent contact, causing intermittent function, but works. So lastly, what I'm going to do is I'm going to go over in the schematic what we just did and what those chips do, as well as what that one capacitor did. So close all this up. This is going to go in queue in status for ultrasonic cleaning, because we obviously can't leave that. And also, I think something with the fan circuit, but my fan might be bad, so I'll have to use a different fan. Okay, so let's go to the schematic. Alright, so where were we? On this side of the board. And our issue is with right here C8312 and U8300. So, alright, so grab my keyboard. So obviously this is our regulator for the screen. What this is going to do is take EDP panel power from the CPU, which is going to be basically the enable pin on this chip, and it's going to take VV3S5 and turn this into the output for the screen. You're not going to get image if the CPU is not sending this out, so if you're passing post, none of this is going to come up. And then this was the capacitor that was corroded, just a decoupling cap for 3v3S5 and for output, but it's still, if the chip was failing, putting out Ripley voltage, that could cause you not to get your image on the screen. That's pretty much it. Our main issue isn't going to be in this circuit. Everything else in this area looked pretty good, and that's about it. So thank you guys for watching, and I'm going to try and put up more of these videos more often since I took a break from it, and I'll try and start filming some of the more interesting repairs. Usually when I do a live stream, it's on a junk board that I put off all day until the night, and you get a really lousy live stream that's not fixable because I waited to do the stream on that one. So I'm going to try and get a lot more of the fixable ones up there. So thanks for watching, and I'll see you in the next video.